Hey there, it's Nicholas. Today's subject is aviation. This is my own creation here. I am very, very proud to. Well, I wouldn't say proud, but come on, who hasn't invented their own flying vehicle before? I think that is pretty cool. This is a blimp helicopter train drone linear motor. Imagine a helicopter, but 20 times bigger, 20 times longer, so forth. 8 rear propeller rudders. What is this? 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 20 helicopter rotors. And I'm using a bunch of these small space thrusters for forward propulsion. And what I'm doing with this particular design is just showing off how much can this thing lift. And underneath, there's a giant lead weights. So each one of these lead weights at the bottom weighs. The physics on this game isn't exactly like the physics in reality. Okay, let's see here. So this game says this thing weighs. How heavy is this? Well, let me build. It's too big. That's the thing about it. It's always telling me there's not enough space for these larger builds. Why is it always telling me it's not enough space? Okay, there we go. This weighs 8,000 kilograms. And I think in reality, this would be a lot heavier. But I think they reduced the weight on this video game to make it more fun. I don't know. But I think in reality, this big chunk of steel here, this is the heaviest. These parts are the heaviest pieces of metal in the game. It is like heavy weight block, 50 kilograms. So this is running on maximum complexity. I can't make it any more complex. Well, I can probably make it about 200%, 200 blocks more complex. But I just wanted I could probably make this lift a lot more weight, and I could probably make it a lot more powerful and all that stuff. But this is already a heavy lifter. Blimps in the center, a blimp chassis, train caboose with helicopters, helicopter rotors, engines, gyros, and all that stuff in the back. And only the rear ones have the rear rudder. Big rocket nozzles in the back. So, what I was trying to get to is saying that these big, heavy blocks here weigh about as much as a tank. If you were to give it a realistic kind of approach to the size-to-weight ratio in this video game here, these lead blocks are almost the equivalent weight of a tank compared. I could probably build a tank, but I'm already running on maximum complexity. So, just wanted a basic prototype here to demonstrate the aviation characteristics of this vehicle. I don't know what happened there. It just kind of launched up into the ground. All right, so I used the biggest, heaviest parts and the biggest, heaviest. I added a lot of weight, okay? And so this is not designed to be a fast, maneuverable, speed machine, high performance or anything. This is just a heavy lifting vehicle. And watch the lead weights, press Q. Wait, Z. Yeah, Z. Drop the lead weights. So, and when it's like this, it's a lot more maneuverable. So I just wanted to kind of talk about the aviation characteristics of this concept. So when it's being powered and being and throttling forward, tilted at a slight 5-degree angle like this. Say if it was tilted at a slight 10-degree, 5-degree angle like this. It is using its entire body as a wing. So this is fully loaded. It probably carry more weight, but the equivalent of lifting 3 tanks is impressive enough. You could probably lift more weight. I could probably fit another 100,000 kilograms on this thing. But I went, this is like really pushing the weight up, so I could deflate the blimps and have a maximum speed of 250 miles per hour on a free fall. And then inflate the blimps, and it's very... So, I forgot what it's called, but this type of concept is using almost its entire body as a wing. When it is flying forward through the air like this, it's a linear wing. Instead of horizontal wings going from side to side, like this would be more of a horizontal wing. This concept is linear. So when it is flying at a 10-degree angle like this, it is using the length of the body to lift and control the vehicle. So, kind of like a gyro. The only difference between it, in this, when it's tilted at a 5-degree angle like this, it's working as a type of gyrocopter, wing body gyrocopter, and it's hard to calculate how much something like this could actually lift, but in the simulator, I am lifting almost the equivalent of 3 tanks. And I could probably fit some more weight on this thing. So drop the lead weights and like orbital lasers. I didn't weaponize this thing. So I'm just kind of talking about this concept as a heavy lifting transport logistics flying vehicle for like train transport, cargo lifting and stuff. So I think this thing could lift possibly 3 tanks, 4 tanks. The world record for the heaviest lifting aircraft is a rocket. I think from ground, when a rocket is taking off from the ground and is fully loaded with fuel and such, The a rocket can weigh as much as 45 tanks. Some of these huge, massive rockets can weigh as much as 45 tanks. I'm using the idea of tanks to compare to the size, the weight ratio. Okay, I think people understand the size of a tank and know that they're very heavy, and they're not all the same. They all weigh different weights and so forth, but they all, a big heavy tank pretty much all rounds off at around the same weight because they need to be transported on trains and stuff. They transport the tanks on the trains. So you need to get the tank to fit on the train. So they're generally about, give or take, a few extra 100,000 pounds or something. Tanks generally weigh around the same weight. Heavyweight class. Okay? So, thinking about heavy lifting vehicles. And so I think this is the best way to maximize lift from a aviation concept, because using the helicopter rotors, using thrust gyrocopter concept, and you're using the entire body of the wing, the length of the wing, of the body, to act like a giant wing that can lift a lot of weight. So the more weight this is going to carry, the more it would tilt at an angle to create lift. And it's also using a very large blimp chassis. And I wasn't even really trying. I gained a lot of altitude pretty fast. So, I suppose you would say it has a fairly accurate kind of physics to the size to weight ratio of this sort of thing. I think in reality, something like this would probably weigh like 200,000 pounds in reality. But in the simulator here, it says I'm only lifting 10,000 kilograms. But I think in reality, something like this, lifting all these heavy weights at the bottom, would weigh 100,000 pounds something. So, okay. I think, this is so that's what I'm doing with this concept, is trying to think about how to lift the most weight. How do I transport the most weight from across the map? I don't know why, helicopter trains, that's a pretty cool concept. That's what you want to do. This would be like a kind of cargo shipping delivery vehicle of some type. You don't need. So this was the idea. Idea of this kind of aviation concept to replace shipping container boats. Say if you got a bunch of shipping containers in China, and you need to transport it to the United States. This isn't going to carry as much weight as a shipping container, okay? But instead of this, you would probably be able to carry maybe 10, 20 shipping containers, possibly with something, if it was bigger and longer and a lot more advanced or whatever, you could possibly transport 20 shipping containers. And I think you get those shipping containers pretty packed with some heavy stuff. Possibly you could transport 20 tanks. if this was bigger and better, but I've maxed out the complexity here. So this is as complex as it could get. So see, like at this angle, it's very floaty, it's very stable, it's not fast, but it's very controllable, and it's not designed to be like a fast and maneuverable. It's designed to be a heavy lifter. And, you know, that was a fairly soft landing. So, using this body warping, the body, I call it, the Wright brothers called it wing warping. I call it chassis warping. And it's a way to have a very powerful yaw with this type of aviation concept. Because if you think about it, it's a flying train. It has tons of inertia and momentum. So say like this thing is going forward 100, 200 miles per hour. That is pretty fast for a big, gigantic flying vehicle. 200 miles per hour for this big, gigantic flying vehicle is pretty fast for a helicopter. Helicopters are not fast, okay? But that feels about right. I think it would. So, so you have 100,000 pounds, 150,000 pounds of mass moving forward. That's a tons of inertia, momentum, and kinetic energy. It's not easy to stop a train. Once a train starts moving, it doesn't want to stop. It's very hard to stop. It's going to take a long time for it to stop because all that mass and inertia just keeps pushing the weight forward. So what this chassis warping is doing is displacing the weight, all the weight of that is carrying into this type of chassis warping that is, so say it's like its chassis is turning left. Each engine is thrust vectoring left. The chassis of the vehicle is displacing airflow left. The entire chassis of the aircraft is a wing, right? So when I yaw left, I am using like 4 different types of yaw. I'm using the rear rudders to yaw, and I'm using the body of the vehicle to yaw. I'm using the engines of the vehicle to angle and yaw. And I'm using gyros to yaw, left and right. And then pitch up and down, I accelerate and decelerate the helicopter rotors at the front and back. So accelerate, so I pitch down, accelerate rotors at the rear, pitch up, accelerate rotors at the front. And then, I forgot the rear rudders. It probably doesn't even really need rear aircraft rudders. I used helicopter rudders, but that's one thing I forgot about this thing. I probably should have added some aircraft rudders for stability. That's one thing I forgot with here. Need to add. I don't know if I have enough room at the back. I don't think. Probably going to need to make the back longer. Yeah, that's why I didn't do it, because yeah, the propeller blades are going to hit the here. Let's try that. All right. Looks like the propeller rudders might be coming pretty darn dang close to hitting the rear rudders at the back there. But anyways, what I'm saying is that the train helicopter has a very powerful yaw, and that is what you need if you're transporting a lot of weight like this. You're going to need a very powerful yaw, because see, I'm still going backwards. I'm still going negative 30 miles per hour, because I was going forward at 100 miles per hour, and then I yaw left, and I'm still going 40 miles per hour in the same direction, because the mass and inertia is pushing me forward. So I'm going 200 miles per hour, 200 kilometers per hour right now, and I'm yaw left. And it's like I'm still going the same direction, pointed in opposite direction at 70 miles per hour. You know, and you have to use all those engines to thrust vector and start pushing the aircraft in the opposite direction. So that's the interesting thing about this train, is that trains are very hard to stop. Once a train gets going, it's going to take a long time for it to slow down, because all that mass and inertia and kinetic energy just wants to keep on pushing forward. So by having this powerful yaw like that, you are able to harness that inertia and momentum and forward momentum. So, okay. Next part is the airflow. I forgot to mention that. Okay, back to where I started off with talking about how this aircraft, when it's tilted in a gyrocopter mode, I suppose you would say this is the gyrocopter flight mode for this aviation concept. When I'm thrust vectoring forward using the propeller, so the airflow is pushing straight and I am angled upwards at a slight 5-degree angle, right? So the entire aircraft is acting like a giant wing. The airflow coming from the side is creating a vacuum on the top of the aircraft. So a large vacuum bubble would, because you can't do that with a wing, because the wings don't displace the airflow. It's slightly displacing the airflow at an angle to provide lift on an aircraft. You can't do this inline concept with a whole bunch of wings, because you're not displacing the airflow. Helicopter rotors, drone rotors are displacing the airflow. They are pushing the air down. It's a type of thrust vector. So when the aircraft is carrying a heavy load and flying forward, tilted at a slight 5-degree angle like this, you are creating a massive low pressure bubble above this aircraft. So the airflow is coming in from the front and being pushed down across several thousand metric square feet of airflow. Not to mention, this is as aerodynamic as you could possibly get it from the front. I use intake, aircraft intake. So it is very aerodynamic. Has a very small profile. That's another reason why the train concept works, because from the front it has a very small profile, very limited air resistance, and so it's very aerodynamic, like an arrow. This is very aerodynamic for its size and weight and all that stuff. I would consider this to be very aerodynamic this is a huge, massive vehicle. This is probably as aerodynamic. Yeah, you could probably get it a little bit more aerodynamic, whatever. This thing is so slow, you're not going to, I mean, you're lucky to get, I think that's good enough to get 200 miles per hour out of it, you know. So, what I'm saying is that, you know, you're creating a high pressure bubble below the vehicle, and then creating a low pressure bubble above the vehicle. And so it should be very efficient and very effective at transporting heavy weight, because this is a gigantic, massive vacuum bubble above the aircraft. When it's flying forward, all that 1,000 metric feet of air is being pushed downward at like a 5-degree angle. So it should have a incredibly effective lift wing body type of effect. So this is a unweaponized here. So I also have, let's see if I could, let's try a different one here. I think this one is, yeah, this one's weaponized. This is a very heavy weaponized gunship with 3 tank turrets on the sides, and it shoots these, I use the biggest heavy guns in the game to shoot in all 4 directions. I'm shooting forward, back, left. Probably could have some guns shooting downward as well. But with these side-mounted guns, I'm able to, you know, get an angle. So use the biggest heavy guns for this gunship here, and this thing should be able to take on just about anything. And it's got shields. This is very heavy, armored flying tank. Let's see how much damage this thing can take. Let's go do some dog fighting over here. This is probably a bit too heavy, but it's got tons of shields on it as well. So each shield is also very heavy as well. I think I maxed out the complexity on this. It's got some pretty good, powerful guns on it. Let's go do some. Mission complete. Okay, let's go pick up the chip. Oh yeah, it's also a bus, Airbus, so Let's go pick up the rescue the birdies. So yeah, just took out this entire base here and 4 aircraft without even trying. Come on, get in, guys. What's going on? Rescue the Chipperoos. Get in. What? I don't have enough seats? B. I've already maxed out the complexity here. All right. So, yeah, didn't even try and destroyed this whole base. So, just blows up everything. Probably could use some downward facing guns just to blow up stuff in the ground as well. But, yeah, pretty much just fly in and this thing shoots massive guns in all 4 directions. Pretty cool. Carries a lot of weight, very armored, very heavy, very slow. Let's see here. F2. F1. I don't know if anybody's ever thought about this, but a big gigantic drone. With just a whole bunch of guns everywhere. Really good tank turrets at the front and back. This is pretty effective. So, yeah, kind of interested in heavy lifting vehicle concepts with this game. And I think the concept is pretty darn dang cool. The ability to lift cargo and transport it. So normally with like logistics, transporting a bunch of cargo from China or something, you need to load it, you need to take it from the manufacturer, put it on a semi-truck, take it to a ship, load the shipping cargo freight container onto the ship, transport the ship across the ocean, put the cargo on a truck, put the shipping container on a train, transport the cargo across the country on a train, put it on another truck, transport the truck to the delivery. With a heavy lifting vehicle like this, would be able to pick up the cargo from the manufacturer, transport it across the ocean without using a boat, without using a truck, without using a train, just direct from point A to point B, from the manufacturer directly to the delivery, without using a truck, train, or boat. See, like this town here, delivering the cargo. Here's your lead weights. Okay. So yeah, it's just really cool to fantasize about this type of vehicle because I don't know. I love vehicle designs. You know, it's like, who doesn't like what kid out there doesn't like trains? You know, and trucks and big boats and stuff. That is really freaking cool. You know, like, you know, so like a little kid in us that just loves big monster trucks and big trains and big boats and stuff. This kind of fits all four in one. It also floats because it's a blimp as well. It's a very effective floater. It's got a bunch of blimps on it. There's no water around this map, so I can't go swimming. But yeah, it floats. It's safe because it's redundant. I have like 20 engines, 8 rear rotors, 8 gyros. Maybe I think I probably have more gyros. 20 helicopter rotors. So normally with a helicopter, say a conventional normal helicopter, if anything goes wrong with a normal helicopter, traditional normal helicopter with using one rotor, one engine, rudder, gyro, whatever, if anything goes wrong with your gyro, if anything goes wrong with your engine, if anything goes wrong with any part of the helicopter, you're in big trouble. You're in big trouble. If anything goes wrong with your helicopter. But this is redundant. So if I lose an engine, I got 20 more engines. If I lose a helicopter rudder, I got 8 more rudders and 20 more rotors. So I imagine a vehicle like this would be very safe because it's redundant. And it's technically a flying tank. I really do not trust helicopters because they are fragile. If anything goes wrong with any part of a normal helicopter, you're in serious trouble. But something like this should be a lot safer. It should be so much more safer than many other type of vehicles. So everything works on the simulator here, and I think it would work just as good as it does on the simulator. It also has a type of mech robotic type of aviation concept, if you think about it, because it's chassis warping, it's flexing like a fish, right? Kind of like a flying snake, I suppose you would say. So it has a type of ornithopter. I wouldn't say I'm not using mechanical wings like an ornithopter. I'm using a type of it is a mechanical wing in a way, you would say. I suppose you would say it is a type of mechanical wing, but it's a linear mechanical wing, not horizontal. It's a type of mechanical linear ornithopter wing that flexes left and right like this, right? So that's what is so cool about this aviation concept. It's using ornithopter mech-like robotics. Oh, it could get really complicated with all kinds of modifications. There's so much detail that goes into something like this. But, for example, I'm using detachable blocks here. I drop the weight, and it become a lot lighter. But I could also, like, instead of dropping the weight, I could probably detach the drones from each other and have the drones operate independently, like a transformer. It's a transformer. I need to do that next. I haven't got around to that. That's going to be very complicated, getting each caboose to operate like a linear drone swarm. It's a drone swarm. So this is a list. This is a gigantic list of all the type of aviation concepts of this type of vehicle. It's a linear wing. The aircraft is technically a flying wing. Okay? It's very similar to a flying wing concept. It's similar to a ornithopter flying wing, but it doesn't flap up and down. It flaps side to side. Right? That's for the yaw. So mech robotic transformer drone blimp train helicopter drone. It's using many. Probably, I think it might be using almost every aviation concept that you could think of. I'm even using rockets, thrust. So and there are some jets at the bottom to help pitch yaw up and down and stuff. It probably needs more powerful pitch and yaw up, pitch up and down. Pretty slow with a pitch up and down, but it's a flying train, so you're not gonna get like high speed maneuverability and performance out of something like this. Okay, so very safe, very redundant backups on the backups. I've already maxed out the complexity, but it could be a lot more advanced than it already is. It's technically a UFO. I think you would consider this technically a type of UFO. I mean, what's better? Okay, so what? Whatever. I'm not using advanced alien tech here, but it's technically a type of UFO. I would say it's almost as cool as a UFO. A flying saucer. I would say that this is almost just as cool as a flying saucer. UFO. And it's not that this one is... I'm just thinking about how this would function in reality and so forth. What else am I missing here? All right. I heard DARPA is having a heavy lift competition, and I'm on a budget eating beans in my shack, and I would love to build some small-scale prototypes of this. But like I said, what's the point of even contacting DARPA, the deep state industrial military complex? They're gonna be like, you're not a part of the club. You're not allowed to be a part of our heavy lift aviation contest. And I'm pretty sure DARPA knows exactly who I am. And they got their eyes on me, and they're looking at me like, yeah, we'd like your aviation concepts, but you're human. Humans aren't allowed, or something. I don't. If you ever listen to Coast, man, they pretty much talk about how freaking what crazy the aerospace industry is. I think getting involved with the any of these industries right now is a bad idea. Is what I'm thinking. I think I would like to possibly get into the DARPA heavy lift competition, but the deep state industrial military complex is freaking weird. But, you know, I'll probably email this video to DARPA and tell them, hey, this is how I would build the heavy lifter. And I'm not surprised none of you offered me an opportunity or a job, because I'm not interested in joining your club. Deep state cult is freaking weird. They'll eat you. So that's another thing to consider when getting into aviation here. You have to consider the deep state government aerospace creeps that are probably gonna eat you. I don't trust the deep state military industrial complex. I do not trust them. So that's another problem trying to get involved with this. So I pretty much use these big giant weights for like a ski at the bottom. Just a very simple kind of landing gear. And come on. Hello, anybody. I'm going to spam this video on my social media platform, and I'm looking for people interested in aviation that want to help me build some small-scale prototypes of my linear drone train heavy lifting concept here. But everything's fake and gay. Everything is fake and gay these days, so hello, we got to build these drone trains and transport cargo from other countries directly from point A to point B. Take off, transport, land, and drop the cargo. Dropping the cargo. Here's your metal. All right, then we're taking off and going to China to pick up some more cargo. We don't need a train, we don't need a boat, we don't need a truck. Just load it. If it fits, it ships. All right, let's get these drone trains going, y'all. Hello, Mr. Trillionaire aerospace industry guy, Elon Musk. I know you like my drone train. Let's build some drone trains here, Mr. Elon. We got to transport cargo from China to your shops and stuff. All right. Bye-bye.